the ambiguous case, which may be somewhat ambiguous. So it's the ambiguous case of the sine law. So solve for theta if sine theta is 0.8333. So first thing we do, each calculator's out, make sure it's in degree mode. You do the inverse sine of 0.833. Now I'm going to check, so I'm just going to go sine 30. It says 0.5, so I know it's in degree mode. I could also check the mode, but so we want to do an inverse sine on 0.8333. Which goes, so if that were negative 0.8333, I would still be doing it on positive 0.8333, right? So we want to get the reference angle. So theta ref will go to 1 decimal is 56.4 degrees. Okay, now we go back to the original and we say, well, the sine is positive, so which quadrant or quadrants is it in? Okay, so theta is in Q1 or Q2. And then we get the angles, right? So we can sketch them. I mean, the quadrant 1 angle is kind of obvious, right? And the quadrant 2 angle, this is 56.4, and this is degrees. And the other angle is it's going to be like 180 minus 57, so 180 minus 173. 123.6. All right, so when we're using sine or inverse sine, right, we're finding the angle whose sine is something. We're always going to get two answers, right? Quadrant 1 angle and a quadrant 2 angle. Now this can lead to problems then when you're doing triangles like this. So, for example, let me show you. I'm going to just, that reference is out of date, or it uses Java, which isn't in here. But so non-right triangle. You've got a non-right triangle. You're dealing with side-side angle. Okay, so this side is defined, and this angle. I'm going to say show ambiguous case, right? So here's the triangle, right? There's triangle, everything's good. So show ambiguous case. That 4.6 could be out here, but it could also be in here, right? And that would still have a side of 7, a side of 4.6, and a 28-degree angle, right? Side of 7, side of 4.6. Angle of 28 degrees, which is opposite the 4.6, whether it's here or here. Okay. If I change the 4.6, pick up the slider, and move it, now we can get to the point where, oh, you know, like it is a right triangle. Well, not quite, right? We go down, we get to the point where it is right. We can also get to the point where this side won't make a triangle, right? So you see this is too short, this side, right? And this is predefined, right? They have told us that the side opposite the 28-degree angle is this size. And they have told us that this side is this size, and they're asking us to make a triangle. Well, so, you know, this has to be long enough, right? Just long enough so that it matches, makes Pythagorean theorem, makes that a 90-degree angle, right? I don't think 3.2 is quite it, but, you know, we could figure that out, right? Like what side. If this were a right angle triangle, then this would be the length, right? And there would only be one possible triangle. But if it gets longer, you know, up to, it can't get to 7, right? When it gets to 7, it's going to flip to the other side. And, you know, it's not going to work either. So we need it to be within a certain range. But when it is, we have these two triangles. Right? And I could change this angle. And I could change this side. Make it longer. Right? And if it gets too long, well, then this side needs to be longer so that I can at least get a right angle triangle. And then as soon as I make it longer still, then we have this ambiguous case, right? And the reason is, it's this angle here. It can have one of two values, right? So this is opposite the 10 degrees, right? Now depending, remember, sine of an angle, you got two values, okay? So we have a ratio, and that ratio gives us an angle, but that angle could be this angle, could be this angle. So we've got to work that out. Or we have to take into account that can happen. So in triangle ABC, determine the measure of angle C if angle A is 30 degrees, C is 20, and little a is 10. Okay, so we have little a is 10. Call that little a. All right, so we can use the sine law, right? Okay, what do we want to find? Determine the measure of angle C. So this is angle C. So we know that the sine of C over little c is the sine of A over little a. Okay, that's sine law. That's the form we use when we're solving for an unknown angle. Okay, put the angle up top. So sine C is equal to C times the sine of A over little a, and C is equal to the inverse sine of, so in this case we can fill in all the numbers now, right? So we've got little c is 20 times the sine of 30 degrees over 10, and so what do we get? Let's clear this. Second sine inverse, okay, 20 times sine 30 divided by 10. Okay, this takes me right to the angle, right? So now if you get a weird number for this, and by weird I just mean like really small, then just realize, oh, I found the sine of the angle, I haven't found the inverse. And we're 90 degrees. Oh, okay, well then this thing really should have been drawn like this. Great, that's a 90-degree triangle. Okay, so angle C is 90 degrees, and that's unambiguous, right? There is only one triangle you can make. That's the case where that line is just long enough to come down and make a 90-degree triangle. Now we can tell what's going to happen here if it's 8. Okay, so we know this is 10. I mean, if it's 8, it's just going to be hanging down here, right? Okay, we don't necessarily know that, right? Not from the information given. I don't know that, hey, if I do an 8 there, it's too short. But let's see what happens, right? Like, what does this case give us? So we do the same deal. Okay, so same stuff is up there, right? So C is equal to the sine inverse of, okay, we've already done the formula once, right? We're just doing repeating stuff, so it's okay to not generate the formula each time. So we've got 20 times the sine of 30 degrees over 8. All right, let's go back here. I can just hit second function, enter, bring that back down, change that to an 8, get rid of the 0. And I get, value entered is not allowed in the function or command. Error domain. Okay, you get something else, right? You just get error probably. Error means you can't do that. Okay, you can't do that. It can't find an angle such that that is true, right? Because you can't actually make a triangle out of it. So if you get error, you're dealing with this case. Okay, so you get 90 degrees, we're dealing with a right angle triangle. You get an error, you're dealing with the case where this side isn't long enough, right? You can't make a triangle. Okay, so no triangle possible. And lastly, if it's 12, well, we know what's going to happen if it's 12, right? There's going to be two possibilities. Now, we're pretty much kind of hardwired to look at this possibility, right? Because I don't think we draw in our triangles with an oblique angle. We like them. All right, so let's work it out. So let's say we draw that, right? That's little a. That's little c. We want angle C, so same deal, right? So C is equal to the sine inverse of little c, so 20 times the sine of 30 degrees over 12. I'll do that. Okay, quit. And just bring that in. and I want a 12 here, 12, and 56.4. Okay, seen that number before. So this angle here is 56.4 degrees. So C is equal to 56.4 degrees. Now you're going to say, but wait a sec. Since that's a 30-degree angle, that's 30 degrees, then this angle could be 56.4, right? But all it says is that the inverse sine is 56.4, and then we got to say, okay, it's 56.4, but it could be in quadrant 1 or quadrant 2, right? It could be quadrant 1 angle, it could be quadrant 2 angle. Go back here, we got 56.4. We say the other angle could be 123.6. Okay, how would I draw that? Well, we would draw the 12, so we're here, and that makes this angle 123.6 degrees. So when you're doing the sine law, and the situation is side-side angle, because side-side angle is not a triangle congruence, right? And by triangle congruence, I mean stuff like angle, side, angle, right? If I tell you, draw me a triangle, it's got an angle of this, a side in between of this, and another angle of this, everybody draws the exact same triangle. If I say, here's the information, I want a side of 20 and next to it a side of 12, and I need a 30-degree angle off of the base, now we get this triangle or this triangle, right? So it's possible to draw two different triangles. So that's the triangle congruence. So the ambiguous case, we have this 30 degrees, we get a 56.4, that adds up to 86.4, right? That's fine. So what if we use the other angle? Okay, so again, we take this as the reference angle. So 56.4 degrees is our reference angle. And the other angle, which is the quadrant 2 angle, is 123.6 degrees. Can you make a triangle? Well, 30 and 123.6 is 153.6. That's less than 180, right? So I can make another triangle, right? So in this triangle here, what do we got? 153.6, so 0.4 will take us to 154. That'll take us to 160, so 26.4 degrees. And if we've got 30 and 56.4, then this angle here, which is now that, is, what do we got, 86.4. So what takes us to 87, takes us to 90, 87, takes us to 180, so 93.6. All right, now you can check it with a calculator, because I don't even know if that's right. But those are two possible triangles, right? So we have two possible triangles. Okay. Now sometimes you have to look in the context of the situation, right? When you're solving these, you got to realize there is an ambiguous case, but maybe within the context that we're solving, it's not ambiguous, right? We need either this angle or this angle, like one of them, but not both of them, right? Or we need both of them. We just need to be aware that they're both possible. Next possibility: what if little a is 25? 25. Okay, so there's our C. So C is equal to sine inverse. Is there any questions on this one, on C, the ambiguous case? Okay, so you can see you can get a right angle triangle. You can get like no triangle. Side's too short, you can't make a triangle out of it. And you can get this ambiguous case. There's two possible triangles, right? Now we've seen it, we've done the GeoGebra thing and this. Okay, so what do we got? Still got the same stuff, right? It's 20 times sine of 30 degrees over 25. And what does that give us? 25. 23.6 degrees. Okay, 23.6. Okay, 23.6. So we have to say, hey, this is like the ambiguous case, right? I have an angle of 23.6, so we have a reference angle. So C, or let's maybe call it C ref, is 23.6 degrees. So what's the other angle? 156.3, right? So C is equal to 23.6 degrees, or one, what'd you say, one? Okay, I got a problem. If that's 156.4 and then I add 30 to it, what do I get? 186.4. So I can't make a triangle that has this angle. Okay, why? Well, so just imagine, right, if this is 25 and I swing it this way, you know, it's going to end up being out here to make the triangle. So I can't have that 30 degrees in there, right? Because I'm going to have to swing it all the way around and back to the other side. And then we've destroyed the, oh, I got a 30-degree angle there. So that's everything you need to know about the ambiguous case. I throw that in. The timing was perfect. Yeah? Okay, so what are the possibilities? It's a 90-degree triangle. There is only one triangle possible. This side is just long enough to make a nice 90. This side is too short. What do you get? You can't solve this, right? You do the inverse sine, it gives you an error. I can't find one. Okay, this is why. It's too short. You get an angle. And you say, okay, this whole sine thing, ambiguous case, then I've got to do the two angles, quadrant 1 angle to quadrant 2 angle. Can I make two triangles? Yes, I can. Here's one, here's the other. Everything's good. In this case, this side's too long, right? Now you're going to know, right? This side's too long because it's longer than this side, right? If it's longer than that side, you can't swing it under. Okay, go back to the... Okay, if this side is too long, the 8.2, okay, so let's see what happens. Okay, go away. Okay, so look, there's only one possible triangle here, right? If this side is longer than this side, you can only make one triangle. Okay, show ambiguous case. There's no ambiguous case. If I make this side, the 6.2, longer, get it over 8.2, right? Then we've got the ambiguous case. Okay, and if I make this, right? So there we are. Too short, you can't make the triangle. Well, it was first we did, right? All right, so there's a 90-degree triangle. Okay, there's too short, you can't make a triangle. You can make a triangle, and then there, yeah, okay, 10's as far as it goes, so we gotta back that up. And you can only make one triangle, right? This side is too long to swing over, right? I mean, if we do, it goes over the other side. Okay, make sense? Good. What's next? So, the ambiguous case may occur, right? Don't guarantee. Using the sine law to determine an unknown angle. So it's when you're determining an unknown angle, not a side. If you're determining a side, you already have two angles. If you have two angles, you have all three angles, right? So there's no ambiguity, right? It's not like, oh, that angle could be this or that. It's like, I've got two angles, so I know all three angles. Okay? I know all three angles and a side, which is a triangle congruence, right? If you know all three angles and any one side, there's only one possible triangle you can draw, right? So this only comes up with side-side angle, or angle side-side, but we avoid that. But just remember that I will be one of those if I try and solve one of those. If the unknown angle theta is opposite the smaller of the two known sides, there's only one solution. Okay? Again, if it's opposite the smaller, because the smallest angle is opposite the smallest side, right? So if the unknown angle theta is opposite the smaller of the two sides, so this unknown angle is opposite the smaller side, there's only one solution. Okay? Because this side can't swing in. So this side, the unknown angle has to be opposite a larger side. Then there's two possibilities, right? Let's make this. Okay. There, the unknown angle is now opposite a larger side than this, and we have these two possibilities. The smaller side can, you know, swing out or swing in. You can have the acute angle or the obtuse angle. Boink. If the unknown angle is opposite the larger of the two known sides, okay, if sine theta is 1, you're just going to get the 90, right? I never solve for sine theta, I always solve for theta. So one solution, if sine theta equals 1, this is if theta is equal to 90 degrees. No solution if sine theta is greater than 1. Again, I always solve for the thing. You're going to get theta is equal to error. Okay, so it can't find a solution, right? So if you just do the sine inverse to find the angle and not to find the sine, and then two solutions if theta is between 0 and 1. If there are two solutions, the two angles are supplementary, right? They add up to 180. Okay, so that is just the angle and then 180 minus the angle. And then the other thing is just check to make sure you actually can make a triangle. All right. So then there are questions. In triangle P, PQR. Peculiar. It's a peculiar triangle. Peculiar. In triangle PQR, determine angle P. So, what do you do first? Draw a picture. Okay? I don't expect you to memorize, right? Like, I don't expect you to sit there and memorize the, well, if this, then that. Okay? That's just silly, right? I mean, just solve it and then say, oh, should I find two angles or one angle? Okay? So, you know, don't go back to that last page and say, must memorize all of this, right? And there's no point in remembering that. Because, yeah, it'll all come out in the water. When you try and solve it, something will happen. You'll get no solution. You'll get two solutions, you'll get one solution, you'll get a 90-degree triangle, whatever. Okay, so PQR. So we draw some arbitrary angle. Well, wait, let's make angle R 110 degrees. Okay, so here's R. That's 110 degrees. Here's little r is 16. Which one of these is P? Doesn't matter. Okay, what are we supposed to do? Oh, determine angle P. How many possible values are there for angle P? Only one, right? Because that's 110 degrees. So as soon as you find it, you can't get an obtuse angle for P. Right? So you got to realize, oh, yeah, I drew that. That's an obtuse angle. They got to add to 180. There's no point in me finding another obtuse angle, right? So we're just going to do a normal solution. Okay, so we set it up. Sine P over little p is sine r over little r. P is equal to the inverse sine of P times the sine of r over little r. P is equal to, all right, what's little p? 10 times the sine of 110 degrees over 16. And, okay, just clear that. So what do we got? 10 sine 110 divided by 16. And my answer is 0.58 degrees. Oh, wait, no, I needed to do a sine inverse on that, right? So P isn't that, right? P is equal to the inverse sine of that. Having forgot to do that here, I'm going to go second. No, I don't want that. I'm going to go second sine, second answer, enter. 35.96. They didn't say we'll round to the nearest, so 36.0 degrees. What? Oh, does it? Okay. Round to the nearest tenth, what is it? 36.0, not 36. Okay. So P is equal to 36.0 degrees. Do we need to work out the other angle, the 144? No, right? Because we have a 110 degree angle. So there's only one. It's not ambiguous, right? It's unambiguous. Angle R is 70 degrees, little r is 11, and P is 15. Okay, same deal. Well, this time I want a 70 degree angle though, so we'll call this 70 degrees. There's R. R is 11. There's P, and there's little p is 15. What do I know about angle P? What can you tell me about angle P? Is it bigger than 70, smaller than 70, or equal to 70? Bigger. How do you know it's bigger? Yeah, P is longer. So angle P is bigger, right? So if it doesn't give me an angle bigger than 70 degrees, then for sure I need the quadrant 2 angle, right? So that's why you draw the diagram. Oh, look, that's larger. Okay, that angle has to be larger. Okay, so we've got the formula, right? So P is equal to the sine inverse of little p, so 15 sine 70 degrees over 11. Okay, what's that give us? Clear. Okay, let's start with the sine inverse this time. So sine inverse, and what was it? 15 sine 70. Make sure you close that parenthesis, right? Divided by 11. What? Wait. $15 sine, did I set it up right? Okay. 15 sine 70 divided by 11. No triangle possible. Okay. So you can't do that, right? That side's not long enough. It doesn't actually reach. So what you're left with is something like this. This is hanging down here at 11. It's like, yeah, okay, it won't reach there. Not with the 70 degree. That angle's too big. Okay. Angle R is 40 degrees. Let's draw a 40 degree angle. It's 40 degrees. Yeah, if you make your diagram, your sketches reasonable, you can sometimes tell from the sketch. Oh, okay, yeah, I can see why that doesn't work. Little r is 12, so this little r is 12. P is 14. There's P. And there's Q and little q. Okay, and we've already got the formula, right? So P, angle P is the inverse sine of little p, so 14, times the sine of angle R over little r. Go to, so 14. Sine 40 divided by 12. And what do we get? 48.58, so 48.6. Okay, now, really that's the reference angle for P, right? Because it could be 2. See, P is longer. So we know it's got to be bigger than 40 degrees. So it could be 48.6. Okay, that's cool. That's bigger than 40. But it could also be 180 minus that, right? So we go 180 minus that. Wow. 180 minus that. So 131.4. Okay, is that possible with a 40 degree angle? Yeah. Yeah, because it's under, right? That'd be 171.4. That's under 180, right? Just makes angle Q could be 9 degrees, right? So in other words, you can swing this side into here, and you get an angle of 131.4. So 2 possibilities for angle P. Yeah? And angle R is 30 degrees, because that's a 9-degree triangle. There's no point in even doing it, but you should do it. How do I know it's a 90-degree triangle?
Because R is half P.
Remember, sine 30 is a half, right? The one angle you have to know, and you can do all the tricks knowing sine 30 is a half. 30 degrees. Okay, this is R. Here, well, it looks like this. That's 7. Like they're opposite. So we got to make P the 90 here. So that'll be Q, and that'll be little p. That's R, and that's Q. Okay, so angle P is the inverse sine of, where is it? P, 7, no, P is 14. 14 sine 30 over 7, and P is equal to 90 degrees. All right, so either you get a 90, you get an error, in which case you just say you can't make a triangle, right? Or you get a value, and then you just work out both values. And then you just say whether or not it's going to work with both values. Yeah, okay, this works with both values, right? Whereas here, well, we could have worked out both values, right? It's like 136, or p is equal to, 144. Okay, but, well, no, you can't do that because you got a 110-degree angle. Okay. So that's stuff to watch out for. So it's the ambiguous case of the sine law, right? You have side-side angle, two sides, and uncontained angle, right? Because two sides of the contained angle is, wait for it, it's the cosine law. Okay. With the cosine law, you have two sides in the contained angle. Okay. With the sine law, you could have all three angles, right? Three angles is not a triangle congruence, right? I can make any number of triangles that has three angles. So I definitely have to have a sine. So if you're doing a sine law problem and you've got two angles, then you've got all three angles, and then you've got a sine, and you can use the sine law, right? Which is easy. Okay, solve triangle ABC. So here's the ultimate question. Solve triangle ABC if. Is this the last one?
Yeah.
All right, cool. So let's draw a picture. 40 degrees, so you can draw a 40-degree angle. 40 degrees, that's angle A. Little a is 12. There's 12. B is 14. Well, the way I drew this, then this will be 14. That's A, B, it's going to be triangle C. So what does solve mean? What do I need?
Everything.
Everything, right? 6 measurements. We have 3 of them, right? Okay. So what do? Well, we just set out and say, what's the only thing I can find right now? What's the only thing I can find? Angle B, right? That's it. Given what we've got, we got to use the sine law. We're going to find angle B. Now we need to be aware, look, it's a side and then a side and then an angle. Okay, so now we should be thinking ambiguous case. Okay, or not. So we just set it up. Sine B over little b is sine of A over little a, right? We got a known pair. Okay, you got a known pair. All right, good. So sine B is B sine A over little a. B is the inverse sine of, and now we can fill in the numbers. So 14 sine of A, which is 40 degrees, over 12. Okay, so sine inverse. Remember, if you forget to hit sine inverse, you're just going to end up with a small number, right? At which point you say, based on my diagram, which may not be perfect, I don't think it's 0.5 degrees, right? So, all right, I've got to do the sine inverse on that. 14 sine 40, close bracket, divided by 12. All right, I got 48.6 degrees. Sounds kind of familiar.
Yeah, we just
Did we? Yeah. Okay, now this is where we step in and say, or, what was the other one then? We did it. 131.4 degrees. Okay, can we do that? Yes, we can. Okay, so we're going to end up with 2 possible triangles, right? And we're going to have to do 2 solutions, right? Because there's 2 different angle C's. So now we say if, so we go over here. If angle B is 48.6 degrees, we want then what's angle C? .4. Okay, that's for purposes of writing on the paper, right? Because we're going to round to the nearest tenth. For purposes of calculation, we're going to use the number that we're going to get out of the calculator. Okay, so we go into the calculator. So I've got this, so it's going to be 180 minus 40 minus second answer minus that one. It's 91 point, and so on. Okay, that's what we're going to use when we go to calculate it. So I want to calculate little c. So little c over sine c is equal to little a over sine a. Little c is equal to a sine c over sine a. Scroll. Okay, so little c is, all right, what's little a? 12? Angle c, sine 91.4 and so on, right? Divided by the sine, and what's angle a? 40, right? 40 degrees. Okay, so we're using this number. So it's 12 sine second function answer, right? Divided by sine 40, and we're on that 18.7. Okay, are there units on this? Is like centimeters or anything? No. Nope. Okay, so then we're good, right? We're just going to go with. So we have, okay, so if you want to summarize this, angle A is 40 degrees, angle B is 48.6 degrees, angle C is 91.4 degrees, little a is 12, little b is, what's little b? 14, and little c is 18.7. And then we just run through the exact same thing again. If angle B then, okay, now, I want this number here, so I need 180 minus this number, right? Now, depending on the calculator you're using, you may be able to scroll up and get that, you may not. So you can always just go second function enter, bring this calculation back down, recalculate that, and then go 180 minus it, right? Because that's the other angle. So we're saying 131.4, right? But we are going to use this whole thing here. So now we got to work out angle C, right? So it's going to be 180 minus this, minus the 40 degrees that's already in there. So 8.6 degrees. Angle C is equal to 8.6 degrees. Okay, now it's not really right, it's 8.58, blah, 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 blah. Okay, so we're going to work out little c. So we'll do it both ways, right? We'll use this number, then we'll use 8.6, just see if it differs, right? So will we get it wrong if we use, right? Or maybe not, but. Okay, so we go down, we're using the same stuff, okay? So just repeating the formula. So c is equal to 12 sine 8.6 degrees over sine 40 degrees. Okay, remember, it's not really 8.6, it's this number. Okay, so 12 sine this number divided by sine 40. 2.786, so 2.8, c equals 2.8. Okay, what would have happened if we'd have gone 12 sine 8.6? 12 sine 8.6 closed divided by sine 40. 2.7, we'd still get 2.8. Okay. But you can see, here's what would happen. What if this were 2.749, which would round to 2.7, and this were 2.751, you'd round it to 2.8. Okay, so this case, you'd get it right. This case, you'd get it wrong. Okay, so just be aware that can happen. You might get away with it. You might not. Okay, I mean, it's up to you. If you're going to pull it on a test, it's like an extraordinarily small part of your mark. If you're going to pull it on a diploma exam, it's a much larger part of your mark, right? Although next year, not so much larger. No, there's numeric response. Yeah. If it was on multiple choice. It's multiple choice, they're not going to give you 2.7, 2.8, 2.9. So if this were multiple choice, they're not going to give you 2.7, 2.8, 2.9, and 3.0, right? The numbers will be more widely split. Okay, but if it's numeric response, right, it's right or it's wrong. So if you're off by a tenth, you're off. It's wrong. Okay, so we go down here and we now summarize. Angle A is 40 degrees. Angle B is 131.4 degrees. Angle C is 8.6 degrees. Little a is 12, little b is 14, and little c is 2.8. Okay, so there are two possible triangles, right? This would be worth like 3 marks on a test. You're definitely going to get one of these on the test. It's like unquestionable. Okay, and this basically is what you're going to have to do, right? You start off, you work out angle B, you say, wait a sec, could be ambiguous case. What are the two possible angles? Can I make two triangles? Yes, I can. All right, then I have to. And, I just need to go through all of this. Questions? Comments? Concerns? What's tomorrow? Tomorrow is cosine law, right? Yep. And then what?